going to see about the topics of crystal defects. Before entering into the crystal defects, we want to know what is meant by crystal. Crystal, a regular periodic arrangement of atom is called a crystal. Regular periodic arrangement of atom. Regular periodic arrangement of atom is called a crystal. But in a regular crystal, some defects are present in them. The defects are called crystal defects. In the crystal defects, there are two purposes we want to study. For what two purposes we want to study means, the crystal defects affects the electrical, mechanical and magnetic properties of a crystal. And for two purposes we are going to study. First one, how these defects affects the crystal. How defects affect the crystal. Second one, how eliminate these defects. Eliminate the defects. So, regular periodic arrangement of atom is called a crystal. That crystals are regular, not perfect. There is some defects present in them. The defects are called crystal defects. The defects affects the electrical, mechanical and magnetic properties of a crystals. For two purposes we are going to study crystal defects. How the defects affects the crystal and how we eliminate the defects. There are four types of crystal defects. Four types of crystal defects. First one, point defects. Second one, line defects. Third one, surface defects. And fourth one, volume defects. Point defects, there are subtopics. First one, vacancies. Second one, interstices. Third one, impurities. And fourth one, electronic defects. In the first we are going to see about vacancies. So in the heading itself we can simply say what is meant by vacancy. Vacancy is an empty atom sites. Point defects are zero-dimensional imperfections. Point defects are zero-dimensional imperfection. In that, the empty atom sites is called vacancies. This is the atom present in the crystal. Here, there is a vacancy present in this place. This is called vacancies. Ion vacancies are called Schottky defect. Ion vacancies are called Schottky defect. This ion vacancy may be single vacancy or di-vacancy, it may be a tri-vacancy. Example, alkali halides. Example, alkali halides. So point defects are called zero-dimensional imperfection. Under the point defects there is a vacancy. Vacancy means empty atom sites is called vacancy. Ion vacancies are called Schottky defects. Example, alkali halides. Next we are going to see about interstitial cis. Interstitials means there is also a empty vacancy, but not like a vacancies. But not like in a perfect crystal. If we give some stress to a parent atom, that one of the atom dislodge from a regular structure and occupy a simple position, that is called interstitial cis. That interstitial cis ion dislodged. Ions dislodged from regular position by using some stresses. This defects, ion dislodging defects is called Frankel defects. Frankel defects. Example, calcium fluoride. In the vacancies, we saw a Scotty defect. In the interstitial cis, we see a Frankel defect. Both Frankel defect and Scotty defect present in a crystal is called intrinsic effect. Intrinsic effect. So interstitials means if we give some stress to a atom, that parent atom dislodges from a regular position. That is called Frankel defect. Example, calcium fluoride. Both Frankel defect and Scotty defect commonly we say intrinsic effect. Next one, impurities. In these impurities, again we can classify it into two types. Substitutional impurity, interstitial impurity. In that impurities itself we can say adding a foreign atom to a regular atom. Foreign atom to a regular atom, that is called impurities. Next, what is meant by substitutional impurity? If we substitute a foreign atom to a regular parent atom is called substitutional impurity. For example, adding a foreign atom. If we saw it, this is a regular atom in a crystal. Suppose if we displace the parent atom, this parent atom, and we can place a foreign atom here. This is the substitutional impurity. So by adding a foreign atom to a regular atom, by displacing a foreign atom, we are adding a foreign atom, that is the substitutional impurity. Next one, interstitial impurity, adding a foreign atom without replacing the parent atom. Foreign atom to a regular atom without replacing a regular atom. If we see this diagram means we can clear this. The foreign atom occupied the void space present in a crystal. Void space means empty side. This is the void space. So this is called interstitial impurity. So impurities, we classify the impurities into substitutional impurity and interstitial impurity. Next one, electronic defects. Electronic defects. So ion defects in a crystal is called electronic defects. Ion defects in a crystal is called electronic defects. These ions can freely move in a crystal. This affects the electrical or electronic properties of a crystal. Electronic defects affects the electrical properties of a crystal. So that's all about point defects.